aldehydes and ketones. What's the mechanism for reducing an aldehyde to primary alcohol? An example of nucleophilic addition, where the H in square brackets is a hydrogen from a reducing agent. It's a nucleophilic addition as the H- ions acts as a nucleophile and adds on to the positive delta positive carbon atom. Where do we go from here? Let's just go from the left hand side and we'll move to the middle and the right side. So the reducing agent to reduce aldehydes and ketones to primary alcohols, the reducing agent to reduce aldehydes and ketones to primary alcohols is NaBH4, sodium borohydride, I think it's called. The two conditions for NaBH4, the reducing agent to reduce aldehydes and ketones back to primary alcohols: NaBH4 dissolved in water, NaBH4 dissolved in water with methanol. Failings. Failing solution is a blue solution of copper 2 ions dissolved in sodium hydroxide. I think maybe crossed out, I'm not sure. And we want to heat this with an aldehyde, and the copper 2 ions are reduced to a brick red precipitate of copper 1 oxide, reducing an aldehyde to a primary alcohol. RC double bond O plus 2 H's, the hydrogen from reducing agent NaBH4 dissolved in water with methanol to form RCH2OH, primary alcohol. Reducing a ketone to a secondary alcohol. This is for reducing an aldehyde to primary alcohol. Now reducing a ketone to a secondary alcohol will also add 2 hydrogens from reducing agent RC double bond O R dash plus 2H hydrogen from reducing agent to form RCHOH R dash. The H- ions come from a reducing agent. They act as a nucleophile NaBH4 on the delta positive carbon atom, and the H+ ions come from the water, which is a weak acid. The ketones don't react with failing solutions, therefore no precipitate, and the mechanism for reducing aldehyde to primary alcohol using H- lone pair of electrons. So, mechanism for reducing aldehyde to primary alcohol, and obviously reducing ketone to a secondary alcohol. In this case, reducing aldehyde to primary alcohol mechanism. So the H- with lone pair of electrons attacks partial positive carbon, transfer electrons to oxygen with partial negative. You get this with oxygen is negative. I'm pretty sure it's got a negative charge as well. A lone pair of electrons, bonds to the H+, and you form your primary alcohol. And this is nucleophilic addition mechanism. So your average nucleophilic substitution, and then the addition of the H+ bonds to the H+, the strong acid catalyst to form your primary alcohol. So now let's go to here. I guess here ketones can't be oxidized by tolerance reagent. Tolerance reagent, colorless solution of silver nitrate. Colorless solution of silver nitrate dissolved in aqueous ammonia, and there's no color change when ketones react to tolerance reagent. So ketones have a carbonyl group in the middle of the carbon chain, whereas aldehydes have a carbonyl group at the end of the carbon chain. And just these tiny minute details to memorize to make the exam easier for you. So when you're in the exam and you have to draw out a ketone or an aldehyde, you know where the carbonyl group is going to be because you're so confident, because you reviewed all of this knowledge. So the aldehydes carbonyl group at the end of the carbon chain, ketones have carbonyl group in the middle of the carbon chain. Equation for aldehyde with KCN: RCHO aqueous plus KCN aqueous, ROH plus aqueous to form RCHOH CN aqueous plus, I think that, plus K plus aqueous. And this is aldehydes. And now ketone with KCN: RCOR dash aqueous plus KCN aqueous, ROH plus aqueous, RCR dash OH, CN aqueous plus K plus aqueous, RC double bond OH plus oxidizing agent O to form RC double bond OH, carboxylic acids. Aldehydes can be oxidized to form carboxylic acids. What do aldehydes and ketones both contain? A carbonyl group, both contain carbonyl functional group. So KCN, KCN is an irritant. It's dangerous if inhaled. It can react with moisture to form hydrogen cyanide, which is toxic gas. It's dangerous if inhaled. Can react with moisture to form hydrogen cyanide, which is toxic gas. And they could test you on your practical skills and that. this chemical. An example of a nucleophilic addition reaction is when potassium cyanide will react with carbonyls. Tollens region, a colourless solution of silver nitrate dissolved in aqueous ammonia. And we use Tollens region and we want to heat in the test tube with an aldehyde. And what happens when you use Tollens region with an aldehyde, obviously not with a ketone because ketones can't be oxidized by Tollens region, a colourless solution of silver nitrate dissolved in aqueous ammonia, no colour change. Ag plus ions in the Tollens region are reduced to Ag atoms, silver atoms. The silver mirror forms. Hydroxynitriles are molecules with a CN and OH group. The carbonyl functional group is C double bond O. So in this case, the aldehydes have carbonyl group at end of carbon chain. Aldehydes have the C double bond O at the end of the carbon chain, whereas ketones have the carbonyl group C double bond O in the middle of the carbon chain. When potassium cyanide reacts with carbonyls, what's formed? Hydroxynitriles. And also KCN is an irritant as well, dangerous if inhaled, reacts in motion from hydrogen cyanide, which is toxic gas. An example of a nucleophilic addition reaction is when potassium cyanide reacts with carbonyls. And that is the end of this video.